Hello. Today we are going to discuss a numerical problem from the portion ladder friction. Okay. So this is the problem that is a ladder of weight 1000 Newton and its length is 4 meter, which is rest against a wall. And if a weight of 750 Newton is applied at a distance of 3 meter from the top of the ladder, it is at the point of sliding. Okay. Determine the coefficient of friction between the ladder and the floor. Okay. So here we need to find the coefficient of friction mu between the floor and the ladder. Okay, so the weight of the ladder is given as 1000 Newton and a weight of 750 Newton is applied, which is at a distance of 3 meter from the top of the ladder. Okay, so with this condition we need to find the value of mu. So first we will draw the free body diagram of this ladder. Okay, so its free body diagram, it's like we know there's a wall of 4 meter which is slanted against a wall, and the vertical wall which is the wall which is smooth, so there is no friction, so we will just have a reaction here, that is RB, and then at the floor we have a vertical reaction RA, and also there is a friction. Okay, so when the ladder slips, it will move to the right direction, so our friction will be left direction, so it is mu into Ra. The friction value will be always the coefficient of friction into the reaction. Okay, then we have the weight, self weight of the ladder as 1000 Newton, which will act at the center of the ladder. So total 4 meter ladder, so it will be at 2 meter from the top or from the floor. Also they mentioned there's a weight of 750 Newton, which is acting at a distance of 3 meter from the top. Okay, and the angle is given as 60 degree with the ladder and the floor. Okay, so this is the free body diagram. Now we need to find out the mu value. For that we are going to use the equilibrium equations. What are the equilibrium equations? Sigma fx equal to 0, sigma fy equal to 0, and moment about a point equal to 0. These equations we are going to use here. So first we are going to use sigma fy equal to 0, that is sum of vertical forces equal to 0. So what are the vertical forces in this diagram? We have Ra, which is in the vertical or up direction, so it is positive. Then we have two loads, that is the self weight as well as an applied load. Okay, so it is acting in the downward direction, so we will take it as negative. 1000 minus 750 is equal to 0. From this equation we will get the value of Ra as 1750 Newton. Okay, so we got the value of Ra. Now we are going to use the equation sigma fx equal to 0, that is sum of horizontal forces. So what are the horizontal forces here? It is Rb, it is the right direction, so positive. Then there is a frictional force, it is acting in the left direction, so it is minus mu into Ra is equal to 0. Okay, so from this we can write Rb is equal to mu into Ra, right? So Ra we know it is 1750, so we can write Rb as 1750 mu. Okay, so we'll put it as 1, equation number 1. Now our third equation, that is moment about a point is equal to 0. So I am going to take moment about this point, moment about A. So it is moment about A is equal to 0. So we are going to take moment. So first we are going to consider Rb. So Rb is going like this. We need to take the moment about this point. So Rb into, this is the vertical distance. This is the vertical distance. So Rb into this distance, perpendicular distance, which is acting like this and making a clockwise moment here. Okay, so it is positive Rb into vertical distance. We know this value is 60 degree and the total length of ladder is 4 meter. So this perpendicular distance will be 4 sine 60, right? So it is 4 sine 60. Now next we have two loads, that is 1000 Newton and 750 Newton. So 1000 Newton is acting like this, and this is the perpendicular distance. So it is, and it is making an anti-clockwise moment here, right? So minus 1000 into this distance. How much is this distance? we know that it is acting at the center of the ladder, right? So from this point, from A to this 1000, it is 2 meter. So here we know this is 60 degree. So this distance is 2 cos 60. This is just applying the trigonometric formulas here. Okay. Now next is 750. 750 is also acting downward direction, and it is also making a anti-clockwise direct moment at A, and it is at a distance of 3 meter from the top, or 1 meter from the floor, right? So it is also 750 into 1 cos 60. Alright, this is a perpendicular distance. This is our perpendicular distance. Alright, and we also, okay, so this much, this RA and mu RA, this both are acting at the moment center itself, so its moment is 0, so don't need to consider. So it's equal to 0. From this we know RB is equal to 1750 into mu, right? So substitute this value. This is 1750 mu into 4 sine 60 minus 100,000 into 2000. 2000 cos 60 minus 750 cos 60 is equal to 0. Solve this equation, and from this we will get the value of mu as 0.227. That is coefficient of friction mu is 0.227. Okay, just apply the equilibrium equations, take the moment correctly, the perpendicular distance, that the one thing you may get confused. So take correctly, apply trigonometric functions, and and we will get the value of mu as 0.227. Okay, try this one.